Now that we have connected all the actions, it's time to start coding. We first need to declare some variables that will be helpful in the program. The first variable that we are going to declare is a boolean. It will capture whether an arithmetic button has been pressed. So let is arithmetic button pressed, clicked, is equal to false. We also need to declare a string variable that will capture which arithmetic button has been clicked. So this needs to be variable. So the second is uh, arithmetic type. This will capture whether it is a plus, minus, multiplication, or division. In the beginning it is set to be false. Then another variable that we need is the first number in the calculation, which is set to be 0. Variable second number is set to be 0 as well. First number and second number will capture the two numbers that needs to be multiplied or divided and so on. When a 9 button is clicked, 9 clicked, this action will be fired whenever 9 button is clicked. So what do we want this to do? When 9 is clicked, in the beginning we want 9 to appear here. So one way is to one way we can accomplish it is by appending 9 to whatever is written on the screen. So we'll do screen label dot text dot append 9. It will complain because the text is an optional, and we know that we haven't covered this in the previous lessons. So for now it is enough to know that sometimes the text is an optional, so we need to write an exclamation mark to let the program know that we know that screen label dot text contains something. It's not empty, because we know it's 0 to begin with and it will be something. So we can be very confident and apply the exclamation mark. So now clicking on the 9 button will append 9 to whatever is written on the screen. So similarly, 8, 7, 6 clicked, all these actions need to have something similar as well, but we'll write that later. Now come to the arithmetic buttons action. When division is clicked, what do we want to do? First we need to keep some checks. First of all, we need to check if screen label dot text is not equal to 0, meaning it is not in the initial state like this, because when the 0 is appearing, we don't want the arithmetic button to be clicked, because that has no meaning. The first number has not been inputted, so that is a check. So this screen label dot text is not equal to 0, and is arithmetic button, where is arithmetic button clicked is equal to false, meaning it has not been clicked yet. Okay, because that makes sense, because if it has been clicked already, we want the equality sign to be clicked and the multiplication to be performed. We don't want, for simplicity, we're not allowing the arithmetic button to be clicked again, or even if we're not even allowing that if you have incorrectly clicked multiplication and you wanted to change it to addition, we are not allowing it for simplicity. So this is the check. And then what do we want to do? We want to obviously, when arithmetic button is clicked, the first number has been entered in the calculator. We want to capture that. So what will be the first number? Then first number is going to be equal to whatever is on the screen label dot text, okay, and convert that into int, because we know that this can be converted into int, because by definition we are entering only integers. So that will capture the first number, okay, and then we'll set is arithmetic clicked to true, and we are also setting arithmetic type to division, okay, that makes sense. And uh, if these conditions are not met, it will be not firing. We need to put again an exclamation mark here. You don't need to worry if there is an exclamation mark that is needed. The program will complain, and it will fix it for you. Uh, so that is division clicked. Now multiplication, subtraction and addition will have similar code. We can adjust this code here. We'll do that in a while. When equality is clicked, most of the action is done here. When equality is clicked, uh, so we need to do some checks. If the arithmetic has been set, so we'll do is arithmetic clicked is equal to true. It has an arithmetic button has been set, and the after arithmetic has been set, some number has been entered. What is a way to check that? Well, whatever is written in the screen, we can set that to, and we can get the last character of that, and screen label dot text dot last, that will capture the last character, and we want to make sure that last character is not equal to any of the arithmetic. Let me just run it to make sure there's no errors. It's a good habit to periodically check there are no errors, because before you go too far you can change it. This has to be equal to true, not equal to true. We're not setting it, we're checking. So it's a check. It has to be equal and equal to. Recall that conditional statements that we did the lesson on. Okay, no mistake. So this is the last character. Let me call it last char for brevity. So last char is not equal to division, because we are making sure that second number has been added. I'm doing it for all the arithmetic. Okay, so that is the last character. Now we need to capture the second number that is there. For example, we need to uh, how will you capture the last the second number? Uh, the second number will be between the arithmetic sign and the end of the string. So I mean, in calculator we'll have something like this: 52 multiply by 98 something. So the second number is starts after the arithmetic multiplication in this case, and will go till the end. So we need to capture the second number in this way. So how can we do that? We need to first capture the index of the arithmetic. So let me just call variable uh, variable screen label, sorry, so variable label is equal to screen label dot text, okay. And what I'll do is I'll uh, index of arithmetic. I'll declare a variable index of arithmetic, I'll call it equal to label dot first index of what arithmetic type. We know that what arithmetic type is entered, so we'll use that. Recall that this is the same arithmetic type that has been captured here and then declared on the top, arithmetic type. Okay, now it will be making sense to you why we declared all these four numbers, four variables. So this is the index of arithmetic. It is showing an error. Let's check. Cannot convert value of type string to expected argument type string dot element aka character. So it is expecting a character here. Recall that arithmetic type contains the whether division, sign of division, multiplication, and so on, but it is still of type string. Since it is going to contain just one character, we can take first of it. So first captures the first character of it, and we need to, I think, add an exclamation mark to it. So index of arithmetic is this. Now we need to capture the index of the last. We need to get the index of the last. We need to get the last index and find the range. So what we need is go to label and index of arithmetic, and then go to label dot last index. End index. Okay, so this will capture the numbers between arithmetic, the range between arithmetic and the end index. It is saying must be unwrapped. Yeah, so this is the label and index of. So this is going to be variable second number string. So it is the string of second number. We need to convert it into. So second number is going to be int of second number. So let's just quickly check that we have not made any mistake. There has to be exclamation mark. Let's print second number string. Recall that the variable need to be put between forward slash and backslash and inside brackets. So let's just quickly run and see we have not made any mistakes so far. So 9 division we have yeah, there's a problem. We need to append division to it. So label screen label dot text dot append division sign to it. Okay, so so 999 divided by 9 and is equal to, it's saying it's a problem. So let's see what that is. Unexpectedly found nil while unwrapping an optional, because we need to, I think this second number is /9. See, so we need to here index of arithmetic, we don't need an index of arithmetic, we need to go after the index of arithmetic. So it has to be label dot index after I believe that will index after, this will fix it. So that will get rid of this uh, uh, this division symbol, because we are going index after the index of arithmetic. So it's very important to strategically run the program and print the statements, so that you can find the problem as it arises. Uh, so 999 divided by 9 is equal to, so second string is 9, which is fantastic. So what do we need now? We need to now do the um, uh, perform the arithmetic. So if arithmetic type is arithmetic type is equal to division, what do we need now? We need to uh, screen label dot text dot text is equal to screen label dot text plus uh, is equal to, and we need to perform the division, first number divided by second number. So if it is, else if it is multiplication, so we need to perform multiplication here. If it is addition, we need to perform addition here. If it is subtraction, we need to perform subtraction here and append it accordingly. So this is how it is done. We need to force unwrap that. So now is the time to think about what needs to go into the clear button. When clear button is clicked, we want the screen label dot text to just show 0 and set the first number is equal to 0, second number is equal to 0, so that calculations can start from the beginning, and also arithmetic type to empty, and is arithmetic clicked set to false. So sort of return all these variables into their initial state where it was started. So, and similarly now it's the time to the division button, whatever is in the division button, correspondingly put that into multiplication and change this and put them into subtraction and change this, put them into addition and change to addition. Similarly, we need to put this numbers into every one of it. So now we are ready to run the program and check it. So let's just perform an addition. 52 plus 8, it should be 60, which it is. Wonderful. Now perform subtraction. uh, 512 minus 12, it's 500, perfect. Now it's time to perform a multiplication. 2 multiplied by 40 should be 80, which it is. Time for division to be performed. 80 divided by 3, it's 26. There is a problem. It needs to be 26.66. So what we need to do is, what is happening here? What is happening is that it is performing the division as in integers. So it is truncating it. So what we need to do is, we need to perform this division as a double. So convert the first number into double and convert the second number into double. Now it will be doing the division into doubles. That's it for the program. If you want to play around, you can try different ways of doing it. You can add decimal point into it, or you can add different functions and run this program. And you can send us in an email. We'll check your program. I'll write the email number at the end in the comments of the video. Thank you very much.